The flagship is launching. We didn't have to wait long for that at all, did we? The 7950X 3D with 3D stacked V-cache. What are we looking at here? This is it. This is what a lot of people have been waiting for, and there really is a lot to be excited about. Is it Intel's worst nightmare? The answer to the 13900KS coming just mere very small amounts of time after the 13900KS launched. It's 16 cores, so it's obviously not just for gamers. Remember that AMD is launching 3 CPUs in the AM5 7000 series that have the 3D V-cache. Previously, the 5000, you just got the 8-core. The 8-core made everything pretty simple. It worked. You had one CCD, one compute complex, with all 8 of its cores having access to the stacked V-cache. Well, not so on the 7950X, which I have here today, 7950X 3D. We have one CCD that is frequency optimized. It's going to run really fast. We have another CCD that has the V-cache stack on it. So in that way, the CCDs aren't exactly the same. Well, it's still 16 cores, it still turbos up to 5.7 gigahertz. It's 120 watts, it's locked for manual overclocking, but you can do PBO, and you can squeeze out a fair bit more performance if you use PBO. Now, in order to make this work on Windows, it does require a fair bit of software. But if you're into Linux, be sure to check out the Level 1 Linux channel, because I also found some pretty good accessibility for the features of this CPU on the Linux side as well. In fact, you have BIOS control. You can tell your BIOS to prioritize the frequency optimized CCD, to tell the operating system via ACPI hints that that is where it should schedule processes before scheduling the other CCD, or vice versa. You can say that the large cache CCD is what you prefer. In Windows, the general approach is that you put games, most games, on the CCD that has the large cache. But as AMD was doing their work and their experimentation for this, that wasn't necessarily always the case. So there are tools now built into the Windows Game Mode functionality. It's sort of what AMD has co-opted and extended in order to be able to deliver this performance with 16 cores. This is the only CPU I have with V-cache right now. I'll be very curious to take a look when we get a chance to look at the 7800, the Ryzen 7 basically, that's a single CCD like the previous generation. But in terms of generational improvement over the 5th gen, it is really, really awesome to see AMD investing the time and materials and headache, because oh boy, there's definitely some headache in getting that working to be able to support different CCDs, different compute complexes that behave differently. One that's faster and one that has a larger cache. Let's build a system and get to testing. Well, of course we're going to test the 7950X 3D in gaming. Although probably that 7800X 3D is going to be the better CPU for gaming, better in terms of cost, but not performance. I mean, if you can get 16 cores in the full gaming performance and you're an enthusiast, why wouldn't you do this? How does it stack up against the 13900KS? I was curious about that. I was curious about that with both Team Green and Team Red, because remember when our 7900 XTX launched, it didn't do quite as well at lower resolutions when we're talking about getting, 400 FPS. And that's really what we're talking about, 400 FPS with Shadow of the Tomb Raider, which I never would have thought was possible on the AM5 platform. Okay, we don't get quite there. I mean, you could put the graphics fidelity settings on low to lower the size of the textures and get there. But yeah, this CPU can do it. And this is one of the titles where, AMD and Intel, they really do trade blows. Unquestionably, I think the 7950X 3D is the better overall CPU. You can get better gaming performance with some games on the 13900KS, but for the games that we're testing, it's a really interesting breakdown. Most of these frame rates aren't really super realistic either. If we start at 1080p and we want to talk about Shadow of the Tomb Raider and Borderlands 3 and all of the games that are pretty common in our benchmark lineup, Team Red, it sort of keeps coming out on top. if you look at games that are not really super memory sensitive, super memory latency aware, it's a little bit of a wash. Things where you've got more CPU frequency to work with are a little bit better. And remember, with our 7950X3D with the V-cache, one of our CCDs is clocked a little lower than our other CCD. So we have one CCD for very high clock speeds, and we have one CCD with lots of cache. It's the best of both worlds. And our scheduling software and some of the other more advanced features that we talked about really come into play here, helping make sure that the game is sort of shunted to the right CCD. Now, there are some interesting things that washed out in our benchmarks. Borderlands 3, Deus Ex, I mean, obviously everybody expected AMD to take the lead here, and they have. It's less headache to get these frame rates from the AM5 platform with the 7950X3D than it is a 13900KS. Our 13900KS, I was rocking our 7200 memory kit from G-Skill, although I did have to loosen the timings just a little bit. Keep that in mind when you're considering these benchmarks. This is sort of the best of what a 13900KS can do for performance and memory speed. And memory speed is going to be the difference here. Memory speed is going to be the difference between an Intel win and an AMD win because, well, our AMD platform is running at DDR5 6000, and DDR5 6000 is a little more attainable on the Intel platform than DDR5 7000 and 7200, which I'll talk a little bit more about in the conclusion, but there aren't really any surprises here. But there was a couple of interesting things that washed out, and that is our 1% lows and our 0.1% lows. Now, our 1% lows, of course, again, having the huge cache really seems to help AMD. But some of the scheduling stuff with our 0.1% lows, there were a few select game runs where Intel would pull ahead in the 0.1% lows. So I'm telling you, subjectively, playing the game and actually, sitting there for 30 minutes or an hour and playing through the game, or a couple of hours as it may have been, the actual gaming experience seemed to be better on the AMD system. But there were a couple of runs where I could get 0.1% lows to have the Intel system pull ahead, significantly, because there was a stutter or something like that during the AMD system. It was very hard to try to capture when this was happening. It may have been scheduling related, it may have been core parking related, it may have been utility related, but this happens so infrequently that I don't even really think that it's a real issue. I think it's just an anomaly in the benchmark because it's not really anything that I noticed in the game while gaming, if that makes sense. But it does show up on the graphs. It does show up in something that you can sort of see and tangibly worry about. And so that may be something to keep an eye on as you play. Now, for other edge case games like Stellaris, this CPU can do about 4 to 5 days in the late in-game stage per cycle. Now, if you're not familiar with Stellaris, it's a 4X game. It's a lot of fun. At the end of the game, you've got so much stuff. It takes a lot of computational horsepower to simulate a day in the game. So when you put it on the fastest setting, it'll just do it as fast as your computer will let you. I'm not sure that I've ever experienced any computer that's able to do 4 to 5 days per second at the end game. It's actually kind of laughable because you keep getting these pop-ups about, because your planets are overpopulated and crime is running out of control, and it's a lot of fun. If you're picking up a 7950X3D and you're going to use anything less than a flagship GPU, it doesn't matter. You may be better off waiting for the 7800X3D, the 8-core, if you want to build a machine specifically for gaming. But for workstation loads and mixed gaming plus content creation, it does really well. When we're talking about Cinebench, the 13900KS still pulls ahead. The frequency loss that we have with the 7950X3D, the one CCD that has more cache, doesn't help us in Cinebench because Cinebench already fit in cache. But for other real-world creative workloads, having the extra cache does help those workloads. So while our performance, the best we were able to get from our 7950X3D was just about 40,000 in the multi-core score, and we're at about 36,000 here with the 7950X3D, even doing our PBO overclock, pushing our Fmax 100 megahertz, which the CPU was actually able to do. So you do get some overclocking. And 16 E cores on the Intel platform plus our 8 P cores is something to be contended with in terms of rendering and everything else. But as a general purpose CPU, I still think the 16 cores that are relatively homogeneous, just varying in cache size, is perhaps a better situation for a lot of scenarios, unless it's just pure rendering, unless it's just some of the other scenarios. So again, it's not as much of a 1-2 knockout punch that AMD enjoyed with the 5800X 3D when they launched it, but it's still a really solid option and definitely a flagship leader in the market here. Let's talk for a second about overclocking. The Vcache CPUs were pretty locked down last generation. Okay, not completely locked down, a little bit locked down. Last generation on AM4, AM5, they're still not completely unlocked owing to technical and engineering challenges, but you can run Curve Optimizer, so you can undervolt your CPU and get more efficiency out of it, and you can use PBO, and you can change the frequency boost max, so it will opportunistically self-boost, up to 200 megahertz. For my testing, my CPU boosting 100 megahertz with the Arctic cooler, 420 millimeter monster that it is to keep it nice and cool, because our new TJ Maxx is 89 degrees C. It worked pretty well, and the efficiency here is kind of off the scale. Meanwhile, on the Intel platform with the 13900KS, when we're looking at 320 watts through the socket as Intel's competitive advantage to push their CPU, AMD is actually squeezing even more efficiency out of their 7950X 3D over the 7950X, which is kind of bananas. 120 watt TDP for the 7950X 3D. Yeah. Surprised? I was too, especially when we look at the raw performance for everything but gaming. It's really not much of a compromise. Cinebench is your worst case scenario, and you're still able to eke out a score of over 35,000. Now, our test machine configuration was a little bit special. Now, this is one of our 2 test systems for the 7950X 3D. This is using the ASRock Taichi X670E, and for storage, we're using the P5800X Optane from Intel with my new Gen Z breakout cable. So it is literally the fastest SSD that you can possibly get. For GPU testing, we use the reference 7900 XTX, as well as our Zotac 4090. Both of those GPUs are running at stock speed, stock configuration, no overclock there. For our memory kit, we're using the G.Skill Trident Z6000 kit, and that is the one with the better timings. And of course, we configured the Expo profile and all of that on the AMD platform, as one would expect. For the CPU configuration, we tested with both the stock out-of-the-box configuration, as well as using PBO and Curve Optimizer to really kind of dial in some settings to get some better performance. But even with the overclocks, we didn't see anything dramatically better. You get 1%, 2%, 3% maybe. No more than 3%. So it didn't really make a huge difference without the overclocking for most scenarios. Multi-core, a little bit of an exception for multi-core performance and things like Cinebench, but for gaming and everything else, not a huge difference. This is our Intel system. We're using the Arctic 420 millimeter cooler. This is an AIO. This is pretty much the best AIO that you can get for LGA 1700. This is rocking a Z790 Taichi Carrera Marble, also from ASRock. Now, we traded the cooler back and forth between the LGA 1700 system and our AM5 system. We also used a more modest fractal 360mm AIO with our AM5 system. And for the AM5 system, it didn't really make a huge difference. For our 13900KS, 6 GHz was basically unobtainable without a cooler this beefy. So your mileage may vary on the Intel platform. We also try to use the G.Skill Trident Z7200 memory kit, and that is a big differentiator on the LGA 1700 platform. If you can get your memory kit stable really fast, then the gaming performance, as we see in our benchmarks, is a little bit better. But I think that's where Intel messed up. See, Intel doesn't really technically bin their memory controller for CPUs. Anecdotally, it seems like the KS memory controller is a little bit better than the K, but I've got a bunch of K processors, and the folks on our forum have had trouble getting their memory controller to work, sometimes even above DDR5 6000 on the 13900K. I mean, obviously the 13900K and 13900KS are the best quality silicon that Intel has, coming out the gate, but there is a variability in memory controller. Our storage and GPU configuration for this system was identical to AM5 for what that's worth, but I thought it was worth taking a close look at these systems since this horse race can be close depending on what configuration you opt for, best of the best or like for like. I'm trying to do a little bit of both. So when we're doing compile tests, we're kind of cheating a little bit here with our Optane P5800X. I mean, this is an 800 gigabyte, $2,000 SSD. If you are a computer science student or someone who is developing games and you don't want, a full fat $5,000 workstation, well, over $5,000, you would be hard pressed to choose a better CPU than the 7950X3D in terms of performance, value, everything else. I mean, yeah, it's $700 plus the cost of the motherboard is, at least another $250, $300. Plus, I'd recommend 64 gigabytes of memory in the form of two 32 gig DIMMs at DDR5 6000. Okay, the price of the system starts to add up a little bit, but this is premium. This is premium AM5, and this is best in class performance until you start getting into real expensive workstation pricing territory. And if you're using Blender, Maya 3D, the Unreal Engine for game development, doing cross operating system stuff. Maybe you're doing some Steam Deck development and you want to boot into Linux or boot into Manjaro and do something. You would be hard pressed to choose a better CPU for those kinds of workloads. And this is really a head and shoulders upgrade over the 5950X and over the 5800X 3D. And you don't have to choose, you get the best of both worlds. Now, if you're looking for just the absolute maximum gaming performance, the 7950X 3D is not for you. I think the 7800X 3D or possibly the 5800X 3D, still on fire sale because, oh boy, that's an inexpensive system potentially, is a really good buy. So who's got the best CPU this generation? Is it a gaming CPU or a flagship CPU? I'll make the distinction. The 7950X 3D is a good gaming CPU, no compromises gaming CPU, but the 7800X 3D is likely to be the gaming champion once again because it's going to cost less. If it doesn't matter to you that much about costs and everything else, I still think the 5800X 3D is a better choice because you're going to be more likely to be able to replicate my results. And this is where I think Intel messed up. The 13900K and the 13900KS, technically speaking, Intel doesn't really bend their memory controller. You're rolling the dice if you get, 6,000, 6,800, 7,000, 7,200, 8,000 and beyond. And in order to get the very best gaming performance numbers, you need the very best DDR5 memory on the Intel platform. It's not really a thing on the AMD platform, for better or worse. And so DDR5 6000 Expo, you can reasonably recreate the values that I show here in this video. To say nothing of longevity and everything else, it just seems like the AM5 platform is a better buy, and there's certainly no compromises on gaming performance. I was perhaps a little bit surprised that I didn't see that much of a performance uplift for AMD's own GPUs like the 7900 XTX, which is a flagship GPU that just launched. But we are seeing performance improvements even at 1440p and 4K, even though I'm sure a lot of the benchmarks today are going to be focused on 1080p gaming. I don't know really how realistic that is, but the larger cache and better ability to juggle lots of background tasks mean that when you're using this CPU and gaming, you can expect that your frame rates will be a little more consistent. And that was true whether you were using Team Green or Team Red GPUs and the game. I worry that the 7900X3D is going to be the odd man out here because that's 6 cores per CCD. How is that going to work with games? How is that going to work with the other performance stuff that we have? I don't know. I've not gone hands-on yet, but I should be getting one probably around the time of this review. So I'll try to have that content out in a week or so, maybe 10 days, something like that. I got to run really quickly and put it together and see how it goes. I have a feeling the 7900X3D is probably going to be more well-suited for the, save $100 workstation. But the cost delta between the 7900X3D and the 7950X3D for 4 more cores, you probably should just go for the 7950X3D. I mean, there's not that much of a cost delta there, especially taking into account the entire cost of the system. You should be aware that the driver does do some really interesting stuff. When you update your BIOS, you get the CPU, you update your BIOS, and you install the latest drivers, chipset drivers, and everything else from AMD. When you do that, you get a new system service that's going to monitor what's going on with your system in the background. It's compatible with the Xbox Game Bar right out of the gate. The Xbox Game Bar, yeah, it's part of Windows 10 and Windows 11, and it has to do with deprioritizing background tasks, because we're entering a world where the CPUs are not necessarily homogeneous, or you actually may want to do core pinning or core priority, or you may want to turn off CPU cores that are mostly idle just to keep processes from bouncing to core because of that cache latency penalty as the cache unloads from one core and loads in another. The scheduler and all the machinery of the operating system will start putting those cores to sleep. Initially, I was very skeptical of actually doing the core parking stuff the way that AMD was doing it, but in actually using the system, I was pretty delighted that it didn't end badly the way that I sort of figured that it would when I started playing with it. It actually seemed to work well for both gaming and mixed gaming productivity workloads. That's enough rambling for this one. I had a lot of fun doing this review. If you have any comments or questions or anything that you want to see, I've got the 7950X and the 7950X 3D. What would you like to see tested, or what would you like to see? What would make a compelling upgrade for you? Or did you get the 5800X 3D on fire sale and you'll be good for the next 2, 3, 4 generations? I know we've certainly done a lot of videos on that, and that would have been a good move. All right, I'm Wendell, this is Level 1. I'm signing out, and you can find me in the Level 1 forums. I love all this cash.